Well, now we will study how electric dipole behaves in electric field. Okay. Today we will discuss about electric dipole, how it behaves, when it is put in electric field. And electric field may be uniform and it may be non-uniform. Okay. So what will happen? So when you put the electric dipole in uniform electric field, like this, suppose this is electric field and this is plus Q and this is minus Q, and this is making an angle theta. So this is the situation. You find this dipole and electric field interaction. What will happen when dipole is present in uniform electric field? It can translate. Can it translate? No, it can't translate, but it will definitely find torque. Suppose this force is here QE and this is negative charge, so electric field के opposite direction में we can find the force QE. Since we have two anti-parallel forces and perpendicular distance between the two forces is, suppose its length is 2L. Consider L, then distance, this is the perpendicular distance, and this is theta, and perpendicular distance will be L sine theta. So this is L sine theta. We can define torque on electric dipole as force into R perpendicular. This is torque. This is QE. This will make the couple, these two force and anti-parallel to each other, and the perpendicular distance between them, and this is a couple. You can see this. Couple means two force anti-parallel, separate, having some separation. So this we have QU into R perpendicular. R perpendicular is nothing but L sine theta. P E sine theta. Dipole moment P is equal to Q into L, charge into distance. So you can express as a vector cross product of two vector P cross E. So this is your torque. Okay. So what happens when you put a dipole in a uniform electric field? We are not getting any resultant translational force because QE in this positive x direction, and this you see QE in negative x direction, and net force will be 0. So net force is 0, but we are still getting a torque, that is P cross E. So this is a case when we are considering the electric field is uniform, and later we see what happens when the electric field is non-uniform. So P cross E. So suppose dipole. So torque depends upon the orientation of dipole moment with electric field. I mean this angle. So torque will be maximum. Torque will be maximum when that is PE sine theta. So that is equal to P into E when sine theta is equal to 1 and theta is equal to pi by 2. And torque is going to be 0 when dipole moment is aligned with electric field. When sine theta is 0 degree, 0, then theta is equal to 0 degree. So, हम लोग देख सकते हैं कि टॉर्क जो है वो एंगल पर निर्भर करता है कि आप कैसे इसका ओरिएंटेशन इलेक्ट्रिक फील्ड से कैसे है, यानी इलेक्ट्रिक फील्ड से कितना एंगल बना रहा है। यदि 90 डिग्री होगा तो इस पर मैक्सिमम फोर्स लगेगा। नाउ यदि ये थीटा बराबर 180 डिग्री है, देन व्हाट इज द टॉर्क? व्हाट इज द टॉर्क? P sine 180 degree, again this is 0. So यदि इलेक्ट्रिक फील्ड के अलोंग ये है डाइपोल जो हमारा है, इसका डायरेक्शन जो निगेटिव चार्ज से पॉजिटिव चार्ज की ओर होता है, यदि ये इलेक्ट्रिक फील्ड के पैरेलल है या एंटी पैरेलल है, इन बोथ द केसेस टॉर्क हमारा 0 होगा। यदि हम इसका मीनिंग क्या है कि जब भी हम इलेक्ट्रिक डाइपोल को इलेक्ट्रिक फील्ड में हम रख देते हैं, देन इस पर एक टॉर्क लगेगा और ये अलाइन होना चाहेगा, ये इलेक्ट्रिक फील्ड के अलाइन होना चाहेगा। ओके, सो व्हेन इलेक्ट्रिक डाइपोल इज प्लेस्ड इन यूनिफॉर्म इलेक्ट्रिक फील्ड, it tries to align with electric field. Okay, so that torque इससे vanish हो जाए, torque 0 हो जाए. Okay, important thing that it will fill torque, and just we have calculated the amount of torque, that is cross product of two quantity P cross E. So we have seen that electric dipole will feel torque when it is not placed parallel to the electric field. Now we will study what happens now electric dipole in non-uniform electric field, non-uniform electric field. Well, this is the question. Okay. Then of course it will feel translational force and torque, rotational force, rotational effect. Okay, so two kinds of the force will act on the dipole when it is placed in non-uniform electric field. We will calculate this force. Okay, we will see the amount of translational force. Suppose this is minus charge and this is positive charge, and this will constitute the electric dipole, and distance between beam is L, and this is electric lines of field, electric field. Then this is the strong field. Suppose यहाँ पे फील्ड ज़्यादा है, आप कह सकते हैं दिस इज अ स्ट्रॉन्ग फील्ड. यहाँ पे फील्ड कम है तो आप इसे वीक फील्ड भी कह सकते हैं, वीक फील्ड में रखा हुआ है. ओके, तो इसे आप नाम देते हैं ए एंड बी. देन एफ ए इज नथिंग बट क्यू ई ए. इलेक्ट्रिक फील्ड यहाँ पे आप मान सकते हैं ई ए है और इस पॉइंट पे ई बी है. देन एफ वी, दिस विल बी इन दिस डायरेक्शन, इस डायरेक्शन में एफ बी होगा और इसके अपोजिट डायरेक्शन में एफ ए होगा. सिंस ये ज़्यादा है, एफ ए ज़्यादा है, तो इसका ट्रांसलेशन इस डायरेक्शन में होगा. ये जो फोर्स ज़्यादा है उस दिशा में ये डायपोल ट्रांसलेट करना चाहेगा. देन एफ बी इज इक्वल टू क्यू इंटू ई ए. Then the resultant force, then we have resultant force is equal to QEA minus QEB. Now we have QEA minus EB. Now we can divide L by L, so we have QL is equal to P, and now we have EA minus EB by L. So this is your force, resultant force, and you can write this. Actually you can say EA minus EB by L is field strength gradient, field strength gradient. So we can write like this: force is P into del E by del L. This is gradient, electric field gradient. So we have calculated the amount of force, resultant force, when electric field is non-uniform. This much you can calculate the forces, but let us generalize it, because we have to use some coordinate system to find this force. Force is a vector quantity, of course, so we need a coordinate system to find this force. Well, so in differential form, we can write force is nothing but dipole moment dE by dx. This is a force, and this is the in x direction. In x direction, this is gradient, electric field gradient. So force must be in x direction. Okay, this is also vector quantity. Dipole, this is also vector quantity. Okay. So we can generalize this statement of this force as Fx, because in this direction E, we see E is a function of x only, and P may be a function of is a vector quantity, so it may be in function of, it may be in x direction or y direction, and the electric field E may be function of x, y. Suppose we are considering in 2 dimensions. So what happens when you are given electric field in a space coordinate and you need to find the force? Okay, this is the conditions actually. I am going to generalize this statement. So in more general way, how will you consider this? Okay, so I am going to write. So one operator you can find Px del by del x plus Py del by del y. When you operate this electric field with this operator, this is gradient actually. So you must study this operator P dot del E, gradient, and electric field. This is the force. But this is a force, but you can understand this very easily. This is the expansion of this one. Okay, but we are not going to discuss this mathematical operation, but you can easily understand this. Also now in Fy, force in y direction, same operator, dipole moment in x direction, del E by del E plus Py del by del y into Ey. So we can now find the force in x direction or y direction. When electric field is more generalized, okay, it is expressed in xy coordinate. Then we need to find the force So, well, we will discuss some numerical problems on this mathematical formula. Okay, so we see in non-uniform electric field, we can find the translation force in x direction and in y direction. When you find these expressions, you can easily solve this and find your desired value of forces in x and y directions. So we will do some numerical problems to calculate this. So you can see that force depends upon dipole moment as well as how the electric field is varying in space, then how fast, or you can see the how rapidly you can see how rapidly the electric field is varying in a space. Electric field is varying in a space. Well, if it is varying faster, then you can find the more force. Force strength is higher. Okay. So whenever you put a dipole, electric dipole, in varying electric field, not with the time, only with the x, y coordinate, then you can find the force, and this is one of the generalized equations. Okay, and electric field produced by the dipole we have just discussed in previous lecture. Now we solve one more problem to understand this basic concept. Suppose question: two dipoles of dipole moment P1 and P2 are aligned along x direction and separated by R as shown in figure. Like this is dipole moment 1 and this is dipole 2. This is your dipole moment and the distance is R. Find the magnitude of force of interaction between the dipoles. Well, this is the question. Okay, so you consider this dipole and it is under the varying electric field produced by this dipole. So we can answer it, we can solve solution. So this force is nothing but we have to calculate. Look, they are in same direction, so we can use the basic formula. It is under the electric field d by dr, and this d is produced by this dipole moment P1. So the electric field, it is in axial direction. The electric field, this is a function of r by dipole 1 is nothing but 2p 4 pi epsilon naught r cube. So how is it varying? Okay, just find del E by del R. What will you get? You will get r to the power minus 3 r to the power minus 4. So it is nothing but minus 1 by 4 pi epsilon naught 2p and 3, that is going to be 6 r to the power 4. This is your electric field gradient at this point, and now electric dipole is present in this gradient. Now you can calculate the force. Each dipole moment P2 del E by del R. So we have P2 P1 6, so 6 P1 P2 by 4 pi epsilon naught r to the power 4. This is the magnitude, 6. This is the magnitude of this force. Well, you have found the expression of the force 6 into product of the dipole moment and 4, this is the 4 pi epsilon naught r to the power 4. This is the translational force. Well, and this is the magnitude. We have found the negative, okay, negative sign. This means attraction force. This means attraction force. If it is negative, this is attraction. Okay, it attracted towards this dipole. So we have calculated the translational force on one dipole produced by the electric field produced by the other dipole. One more question, one more basic question. Okay, a positive point charge Q and a dipole of dipole moment P are arranged as shown in the figure below. Now find the force acting on the dipole. Okay, now this is your dipole, and here charge is kept here, this point, and distance between them is E. And this is figure A, and another question is, this is P. Now Q is here. Now find the force acting on the dipole. Look, you can find the force acting on the Q, and since these forces are action reaction pair, so जो फोर्स इस पे लगेगा न्यूटन थर्ड लॉ के अनुसार अकॉर्डिंग टू दैट वन, ये फोर्स इस पर भी उतना ही लगेगा. तो हम इस पर हम आसानी से फोर्स निकाल सकते हैं, क्योंकि ये इलेक्ट्रिक फील्ड पे रखा हुआ है, ये इलेक्ट्रिक फील्ड प्रोड्यूस करेगा इस पॉइंट पे, और इलेक्ट्रिक फील्ड जो वैल्यू होगा वो होगा, क्योंकि एक्सियल डायरेक्शन में है, 2p 4πε0 AQ. तो यहाँ पर फोर्स क्या हो जाएगा? फोर्स इज नथिंग बट Q इलेक्ट्रिक फील्ड का वैल्यू है 2p 4πε0 AQ. ये इस डायरेक्शन में होगा, तो इस डायपोल पे ये इस डायरेक्शन में फोर्स लगेगा, इस डायरेक्शन में इस डायपोल में फोर्स लगेगा, क्योंकि हमें निकालना है फोर्स एक्टिंग ऑन द डायपोल. सो दिस इज योर फोर्स. आप इसे डायरेक्शन दे सकते हैं -I. दिस फोर्स ऑन डायपोल. ओके, हाँ, हम लोग इससे फोर्स निकाले हैं टू एक्शन रिएक्शन पेयर, और अकॉर्डिंग टू आप न्यूटन्स थर्ड लॉ, you can say that if this dipole is acting a force in this direction, then it is also applying a force on this dipole in opposite direction, that is -I. Well, so similar, you can apply the similar concept in this question. You see this, it is on equatorial plane. So what is electric field at that point? So electric field here, you can find P by 4πε0 AQ, but in this direction, electric field in this direction. So force will be in negative x direction. So we have QP by 4πε0 AQ. This is -I, and this is force on charge Q. Then now force on dipole is opposite direction. Okay, this is epsilon0, and this is distance a to the power q. So this is the force on the dipole. Okay, now we can do the next problem. Okay, we can do some other illustrations. this is your charge Q, and this is plus charge Q, and we have dipole moment in this direction P1, and this is R and this is R. So find the force, acting on dipole. Okay, again with the same concept, you can say that the electric field produced with dipole is this direction. Again, it will produce electric field in this direction opposite to the dipole moment direction. We have P by 4 pi epsilon naught RQ. This is the electric field. Now force will be also in this direction. This is nothing but QP by 4 pi epsilon naught RQ. Similar for this case, this is also the force is equal to QP 4 pi epsilon naught RQ. Okay, so the net force on the system is just you add this force, we get 2P 2F because forces are equal, and this is nothing but QP by 2 pi epsilon naught RQ. So direction of the force on this charge is downward, then force on the dipole will be upward, and this is force. Okay. So we can easily find the interaction of forces between the dipole and the charge. Okay, so let us do some another illustrations. Now we just put P1 and dipole moment P2, and distance is R. This is dipole moment. This is dipole moment P1 and P2 separated by a distance R. Then find the force of interaction. Find the force of interaction. This is your question. Okay, so this is on equatorial plane. This dipole moment is put here, which is equatorial lines. This is equatorial lines and this is axial line. So we have electric field in this direction as, what is the electric field? In function of R, we have P, because it is equatorial plane, 4 pi epsilon naught RQ, epsilon naught RQ. Then force on this dipole is nothing but P, electric field gradient. Okay, this is your force. Just differentiate it with R. We have 3 P1 P2 4 pi epsilon naught R to the power 4. This is the force on this. This is the direction of force. This is the force on dipole 2. Well, this will be the again force in this direction. Okay, this is the expression of the force on dipole 2. Okay, let us do some other problems. Now we have a ring. This is a ring, and this is charge is q, and this is your distance x. This is center, origin, and dipole moment is p1 vector, and it is in this direction. This p is nothing but pi vector. P is pi. Okay. Then ring has radius r. Then find the force experienced by the dipole. Well, it is again under varying electric field, because this will produce non-uniform electric field. You know, electric field is a function of x by the ring q into x 4 pi epsilon naught x square plus r square 3:2. This is the electric field, and this is a function of x. This is non-uniform electric field. Then we have to find the gradient. Then the force is nothing but dipole moment del E by del x. This is your force. Okay, we are lucky now because we are enough fortunate, because we are finding the field and in one dimensions, only in x coordinate. But we will see some problem where electric field will be a function of x and y. Then we will use a general formula for finding the force in x and y direction. Okay. So we are doing the simple problems, and the force only in one direction and one dimension actually, because we are dealing with only one space coordinate. We can do some next another problems where E is a function of x and y, but now you need to differentiate this. Well, we can do some calculation. Well, why don't use x by x square plus r square 3:2. This is a rough work. Okay, so uv, you can differentiate it by x square plus r square 3:2 and a whole square. Now x square plus r square 3:2, x का differentiation is minus x. Now 3/2 x square plus r square and half and 2x. So we have now x square plus r square 3:2 minus, this is going to be cancelled out, 3x square, x square plus r square to the power half by x square plus r square to the power 3. So we can take the common x square plus r square to the power half. Then we have x square plus r square minus 3x square by x square plus r square to the power cube. Well, okay, then we have, this is your rough work and this is, when it comes downward, it is minus 1/2, that is x. We have r square minus 2x square by x square plus r square 5:2. Just subtract this half when it comes under denominator. So we are left with this expression. This is differentiation. Well, now we have force is dipole moment P q by 4 pi epsilon naught r square minus 2s square x square plus r square to the 5:2. This is your answer. This is the force of interaction due to this ring on this dipole, and dipole is producing non-uniform electric field, and like this how it is positioned, dipole moment positioned, you see at some distance x, and with this line, you know, along axial line, and we know the electric field along the axis of the ring, this one, and it is non-uniform, so we can find these forces. Okay, well, okay, just I'm going to do one more problem. So we have electric dipole moment, vector p is pi in x direction, is kept at xy coordinate in electric field. Now we see electric field is under the expression of 4xy square I, function of xy. Look at this. So 4x square yj. Then find the force acting on dipole. Well, now E is a function of xy, then we will definitely find the force fx and fy. Okay, now force fx, we have general statement or general formula px del by del x plus py del by del y into ex. So we don't have y component. Okay, this is going to vanish, but we still have, we can solve this expression to find fx. That is p del by del x, and ex we have this one. What is the value of ex? 4x y square. So we have ex is 4x y square. So we have p into 4y square. Just write 4b y square. This is a force in I. Okay. Similarly, you can find the force Fy. Write this operator del x plus py del y into ey. Again, this is going to be vanished because py is 0. So we have px p del y del x, and ey, this is your ey, 4x square y. So we have p 8x y. So we have 8p x y in z direction. So we have force in vector form. We can write this 4p y square I plus 8p x y and z. So this is your force. Okay, in two directions. So I am talking about this equation. Okay, if you are given with this xy coordinate, then sure you can find the force in 2 dimensions. Okay, so it is rather interesting to find electric on a force on electric moment, dipole moment, sorry. So yahan this is not enough. Okay, I am making a building block so that we can understand what happens when material introduced on the electric moment. We will see the projections so many things. We will understand how electric field, in electric field, how material responds. So I am making a lecture so that we can make understand there. Okay. Because we are going to we will also study solid state physics. Well, so this is your answer. Let us do another problem. Tiny electric dipole of dipole moment after P is nothing but peanut jet is placed at point L0 and there exists an electric field E is 2ax square I plus 2by square plus 2cy in z. So again you have to find the force of interaction. Okay, force on this electric dipole when placed in electric field, again function of x and y. So we can use the same formula, fx is equal to px del by del x plus py del by del y and ex. Okay, then we have dipole moment only in z direction, so this is 0, so this is unavailable for us, this is going to omit it. Now we have py peanut ex is a function of x, and this is again going to be 0 plus 0, this is 0, so force in x direction is 0. क्योंकि ये देखिए आप ये एक्स स्क्वायर फंक्शन में तो y से डिफ्रेंशिएट करेंगे तो 0 चला आएगा. ओके, नाउ एफ वाई इज अगेन पी एक्स डेल बाई डेल एक्स प्लस पी वाई डेल बाई डेल इंटू del y into del y into ey, and ey, this is your ey, and this again is going to vanish because 0. So we have peanut and del into del y is nothing but this differentiated, you will find 4 by plus 2c, and look at this point L0, so y0, so we have left with peanut 2c in z direction. This is your force. Put here y is equal to 0, see this L0, here y 0, so you can find this is your force. Okay. Well, I think this is enough for today. So we have discussed the force on electric dipole when placed in non-uniform field. Okay, it is very easy to find in force in because net force in uniform field was 0, but in non-uniform field it is something you need to learn all these things. Okay, you can find these spaces when you have this formula understand it better, then you can easily find all these things. Okay, force in 2 dimensions when electric field is in 2 dimensions. Okay, thank you.